Here we are going to learn a very important test to check the convergence and divergence of the series. Let's state this test first. It's called ratio test. Let AN be an infinite series. Suppose that we find the limit of ratio of two consecutive terms. You guys notice this is AN plus 1 divided by AN in absolute value. Limit n approaches to infinity. Suppose we find this limit. This limit is L. If that limit is less than 1, then the series converges absolutely. Okay, you guys remember absolute convergence is really strong property. That also that means what? That means absolute value of series converges and also series converges. Okay, if L is more than 1, which is including infinity, then we say the series diverges. So if that limit is less than 1, series converges absolutely. But if that limit is more than 1, then the series diverges. Lastly, if L is equal to n, then the test is inconclusive. That means you need to do some other kind of test. This is not applicable. Okay. So that is what the test is. Let's see if we can tell about the following series. Is it converging absolutely, conditionally, or diverges? I am gonna say this is my AN. I'm gonna try to use ratio test for this. If this is AN, then AN plus 1 will be what? Everywhere where is n, replace n plus 1. Okay. Now find the ratio of AN plus 1 divided by AN. That means limit n approaches to infinity. AN plus 1. What is AN plus 1? 3n plus 1 plus 5 divided by negative 4n plus 1 divided by AN. What is AN? 3n plus 5 divided by negative 4 the power n. Okay. Now, the only thing which is negative here is these. And the absolute value takes care of the negative, right? So what I can write is I can take away the negatives first of all. Secondly, this is a fraction divided by another fraction. What does that mean? The top fraction, which is 3n plus 1 plus 5 divided by 4 the power n plus 1 times the denominator fraction but flipped. So that would be 4n divided by 3n plus 5. You guys notice that I did not write negative signs with 4 because of the absolute value takes care of the negative sign. So that becomes positive. I don't have to write that. Here, n factors of 4 will cancel with n factors of 4. Only one 4 will be left. So we have basically this is equal to limit n approaches to infinity. 3 the power n times 3 we can write plus 5 divided by 3 the power n plus 5, and there is a 4 because this 4, right? Now I need to find this limit. What I'm gonna do is I'm gonna write it one more time to show you. I'm gonna divide all the terms by 3 the power n because that was the highest 3's power in the denominator. Okay. If you guys notice, this here will cancel. So what will be left with? 3 plus 5 by 3 the power n divided by 4, 1 plus 5 by 3 the power n. Now, n is approaching to infinity. If n approaches to infinity, 3 to the power n approaches to infinity. So that means this whole thing is going to approach to 0. And this whole thing is also going to approach to 0. So my limit basically is 3 by 4, right? We have this limit, we found this limit, that is your L. Let's read back the ratio test. Is this less than 1, more than 1, or equal to 1? Clearly, this limit is less than 1, right? So limit which we found, an plus 1 by an, is less than 1. Therefore, this series converges absolutely. What will be your answer? The given series converges absolutely because of ratio test. Using ratio test. So let's quickly summarize that. We had a given series. The question was, is it convergent absolutely or conditionally? Okay. So I used ratio test. I found an plus 1 and an. I divided them and take their absolute value and find the limit. I did all this work and the limit was 3 by 4. 3 by 4 is less than 1. So using the ratio test, the first part, it says it converges absolutely.